labeled my test tubes. Good, like I said in the past, I got this one. I'm going to test out the miscibility of water and methylene chloride. Got my initials on there, MFS, and the date 1/8/21. Water, ether, water, ethanol, water, hexanes, and ethanols, and blah, blah, blah. Got them all here ready to go. So I'm going to start off with the water. Get all the water ones done. And I will get my solvents. I have a water bottle over here ready to go. Easy enough. And then I need ether, hexanes, ethanol. So where do I go? I think all of those are in the flammable cabinet. And they all are flammable. So let's grab them. So here's my ethanol. Grab that one first. And I'll get the, that can of diethyl ether. Grab that one. Yep, remember how I said that ether is very flammable, so we put it in these aluminum cans so you can, if you drop it on accident, it's less likely to break. And you'll see that it will be stabilized with a preservative. Butylated hydroxytoluene, BHT. So there it is. And we keep track of when we open it because the peroxides take time to build up. So if for some reason, like the fat manufacturer forgot to put BHT or something, if it's not too old of a bottle, we can feel pretty safe about it that way too. Okay, so I got that, and then what's the other one we're gonna do? Hexanes. Huh? Let's grab that one again. Hexanes, are you down at the bottom? Oh, methylene chloride, we're going to need that one. Start with methylene chloride. An extra dense bottle. Not bottle. Solvent. The hexanes bottle, when you grab it, you can feel the density of it. That's our most dense one. It's like 1.3 grams per milliliter. And hexanes, where's my hexanes? There it is. Hexanes, mixture of 6 carbon alkanes. Mostly, I saw somewhere that it's usually mostly N-hexane. I don't know for sure. It don't matter. It's just super non-polar. Okay, let's get going here. I'll set up my test tubes. I'll start by adding water to all 4 of these test tubes. About a milliliter to my graduation there. 2. That's close enough. I got all 4 filled up. And now I'll add to the first one. Start on the left for some reason, randomly. I'm going to get out my hexanes. Let me show you how I do that again. So I had a thought that I want you guys to visualize what we're doing here, not just mixing clear liquids, but thinking about the structures, like I said before. So I'm going to draw these out for you now as I do it. So there's the hexanes, a mixture of 6 carbon alkanes. We've got N-hexane, 3-methylpentane, 2-methylpentane, 2,2-dimethylbutane, methylcyclopentane, hexane. So a bunch of different 6 carbon alkanes, linear cyclic. And then we have water, extremely polar, non-polar, polar. So now let's do the experiment. Here's my bottle of hexanes. Open it up, and I'm going to pipette some up and see if it drips out a lot. Squeeze my pipette bowl, draw some up, lift it up. If I'm just holding the barrel, is it dripping? Yeah, it's dripping, not too bad, but it's dripping, and I'm not, you can see I'm not squeezing the bulb at all. It's just dripping on its own. But if I squeeze the bulb and I push out this first amount of hexanes, draw up some more, push it out, draw it up, push it out. I'm evaporatively cooling the glass, so now when I draw up, it won't drip. Okay, so I'm going to come over to my hexanes test tube. Here we go. Add to about a milliliter. Let's see. Oh, this is not looking miscible at all at this point, is it? Not at all, no. and give it a chance, even though hopefully you guessed like I did that the hexanes is too nonpolar to dissolve in the very polar water. But let's give it a swirl, see if this does anything. It doesn't even want to even like kind of start to mix up, huh? Yeah, this looks completely like it is not miscible at all. Let's look at that. See the two layers, obvious two layers, yeah. Oh, immiscible, hexane and water. Next up is the methylene chloride. Let's grab that one. Before we test water and methylene chloride, I got their structures drawn out here. See water again, very polar. Methylene chloride, looks like it could be polar, huh? It looks like there should be maybe some bond dipoles like this, right? Between the carbon and the chlorine, because chlorine's more electronegative than carbon. And not really much of bond dipoles between carbon and hydrogen, because it's so small, the magnitude's almost zero, right? So how's that going to affect things? We'll have to wait and see. Here's the bottle of methylene chloride, or dichloromethane. So methylene chloride, that's usually what I call it. It seems like about half the scientists in the world call it methylene chloride, half call it dichloromethane. So both names are fine. Okay, let's try this one out. Let's see if it's drippy. So open the top, get my master pipette out, squeeze the bowl, and draw some up. Now, I'm not going to be holding the bowl, I'm just holding the barrel. Let's see. Yeah, it's dripping pretty good, huh? And I'm not squeezing it, it's just coming out on its own. So how do I avoid that? Squeeze the bowl, drop some more, squeeze the bowl, drop some more, squeeze the bowl, drop some more. Let's check it again. Oh, look at that. No drips, looking good. And I'm going to add this to my test tube that I've labeled methylene chloride. This one here. Okay, so I'm going to add about 1 milliliter. Getting there. How's it looking? Is it looking like it's dissolving? Oh, it does not. Like a little glob sunk to the bottom. Remember, methylene chloride is our most dense solvent, 1.3 grams per milliliter, so if it's not going to dissolve in water, it will sink to the bottom. Let's try to give it a good chance, though. Let's stir it up a bit. Let's see. Is it? No, it is definitely not miscible. So this methylene chloride does not look miscible in water. So there's definitely 2 layers there. And an interesting thing is occurring. Well, before actually I talk about that, look at the structures. Water we know is very polar. And methylene chloride you might think is pretty polar because it should have bond dipoles for the carbons and chlorines, and it does. But I have a theory about this, that the bond angle between the chlorine, carbon, chlorine is getting closer to 180 because the chlorines are much larger atoms than hydrogen, so they push on the hydrogens like that. So it's not a perfect tetrahedron. And so if those chlorines were 180 degrees apart, they would cancel out each other, so making it nonpolar. So I think methylene chloride winds up being pretty nonpolar. And another interesting thing is if you look at the meniscus. So which layer is on top, which layer is on bottom? Well, the methylene chloride is more dense. It's on the bottom. And its meniscus is like reversed, right? That's the best way to see it. Maybe like, I don't know. So it's going like this, right? So the methylene chloride, if it's nonpolar, that means it's going to be repulsed from the polar glass. So it's going to push away from the polar glass, and it's going to have a reverse meniscus where water on top is polar. It's going to be attracted to the polar glass and climb up it, and also climb down into the methylene chloride. So that's why you have the reverse meniscus on the bottom and the normal. We'll test water in ether next, and here is water, of course, very polar, and diethyl ether. Could be some polarity to it, right? It's got an oxygen to carbon bond that's polarized towards the oxygen. So you got a little bit of polar in the middle, and then maybe the outside you say is non-polar. Let's see how that turns out when we mix the two together. Now for the ever popular diethyl ether, or ethyl ether, or just ether, the most popular ether. So let's open our aluminum can up. See, we got our diethyl ether in there. Ooh, looks kind of cool, huh? And oh, I can already smell it. The fumes of diethyl ether are heavier than air, so they do sink down. I think we wonder if we could see it maybe. If you do, they'll rise up a little bit because they will come out of the bottle. Can't really see it. But let's go ahead and draw a little up and see how it does in the pipette if it drips it on. Just pinch down, draw some up, bring my pipette out. Yeah, I'm not pushing the bulb, that's just dripping on its own. And it's winter. In a warmer lab, it really shoots out. But we can fix it. Push out that first draw some more up, push it out, draw some more up, push it out, and we should be good to go now. Draw some up, let's see. Good, not dripping. There we go, so let's check it. Bring it over to our test tube labeled diethyl ether here. Add about a milliliter. Oh, I did get a drip. Fell out, that's okay. I am smelling the diethyl ether, but I'm not huffing it, so I won't get the giddiness in the future headache. And now I can already cap it. So I've got my diethyl ether in there, and it looks immiscible, doesn't it? But like the other ones, give it a good chance by stirring it. Stir. Yep, looks like it is not going to dissolve. Let's look at it with a nice background and check it out. There we go. So you can see a distinct layer. It's not super obvious. It's not as hard to see the line between the two layers. But yeah. And now, which is on top? What's on bottom? So water is about 1 gram per milliliter density, and diethyl ether is on top. It's about 0.78 grams per milliliter. It's less dense than water. So the diethyl ether is on top, water's on the bottom, and the meniscus is interesting. Along the lower meniscus between the two layers looks kind of flat, huh? It looks like the ether is more polar than methylene chloride, because the methylene chloride had a distinct reverse meniscus. Or diethyl ether looks kind of flat, maybe a little bit normal, but on top it even looks like it's got a little bit of a normal meniscus. Ethanol and water. We already know the answer for ethanol. We know ethanol is the common alcohol that you have in alcoholic beverages, beer, wine, vodka, whatever. So we know that that is miscible with water because you can have 5% ethanol in beer and water, and that's soluble, 40% in whiskey, vodka, and things, and then all the way up to like Bacardi 151, that's 75% ethanol, 25% water, and that's soluble, so it's miscible. But let's double check anyways. Let's see how it goes. So here's our bottle of ethanol here. Let's see if it drips. Squeezing the pipette bulb, drawing some up. A little bit drippy. Let's push it out, drop some more, push it out, drop some more, and there we go. No more drips, looking good. Okay, so let's get this in some water. Confirm that it is miscible. This is my test tube I've labeled for water and ethanol. So we're making right now 1 milliliter water, 1 milliliter ethanol. That's a 50% ethanol in water, so that's 100 proof alcohol. So it looks kind of like it might be immiscible. Let me give a good background for this. Almost looks like it wants to be immiscible. But looking a little cloudy initially, like it's fighting it. And it still stayed a little cloudy. This happens every year, the cloudiness. I'm not 100% sure why it gets cloudy like that. But it is miscible in terms of there's not two layers. I don't see a line between two different solvents. It looks like one solution now. Cloudiness, I'm not 100% sure what that is. It might be that like it's cleaning the glassware, but the glassware was clean. So, I don't know, it's a mystery. The ethanol that we're using is denatured ethanol, and that means they've added things to the ethanol to make it non-drinkable. And then it doesn't have to be taxed like a alcoholic beverage. So they'll add things, generally things like methanol or isopropyl alcohol. Because if you add a little bit of that to that, then humans can't drink it. It's really bad for you to drink it, and you can't. It's not easy to remove the methanol and the isopropyl alcohol from the ethanol because they're so similar. So yeah, it looks like we're going to go with this one being miscible. I searched a little bit to try to figure out about that cloudiness that I see all the time when we mix our denatured ethanol and water. And I thought maybe it was one of the things that denatures the ethanol that causes the cloudiness. Maybe that doesn't dissolve in the water. But then I saw this and I kind of like this idea. So this article is saying that maybe the ethanol has air bubbles dissolved in it, which it does, and it releases air bubbles upon mixing of the ethanol and the water, and that could be just that, as it suggests that the little micro bubbles of air that are released happen because the ethanol and the water, they bond stronger than the solvents do to the air molecules, and the air molecules are left free after the two solvents stick together. And this IPA here is isopropyl alcohol, it's not the beer. So I like that idea, little micro bubbles. That might be the case, and I wonder what I should do is I should take some ethanol and water, denatured ethanol and water, mix them again, and then stir it up and let it sit for a few hours. Because if it is micro bubbles, they probably will eventually bubble out of solution, and then the cloudiness will go away. That would support this idea of the micro bubbles. So just thought I'd let you know. Now I'm going to mix ethanol with hexanes. So the ethanol we've shown is pretty polar, it's miscible with water. The hexanes is very non-polar. We got our 2, 4, 6 N-hexane mixed with some 5 carbon isomers, some 4 carbon isomers, some cyclo, constitutional, not even constitutional isomers, they're different molecules, different number of carbon atoms, but still 6 carbon alkanes. Okay, so let's see if this polar ethanol will dissolve with the non-polar hexanes. I've mixed water with all the solvents we're testing. Now I'm going to mix ethanol with all the solvents besides water. So first I'll add ethanol to each test tube. About a milliliter after that first graduation. Okay, oh, gotta add more. Add a little bit more, not too bad though. Okay, I've got about a milliliter of ethanol in each test tube. Now I'll add to the first test tubes hexanes. Let's add about 1 milliliter and see what happens. How's it looking so far? Looks like 2 layers. I think I see a line there, but let's give it a chance. Let's swirl it around, stir it up. It's getting cloudy as I stir it. Excuse me. Whoa, come on. It's getting cloudy as I stir it because that's usually a sign that it's dissolving. it's dissolved. Here's our hexanes and ethanol, and I believe that is, well, is there a second layer? No, I believe it's miscible. Sorry, I'm shaking it around a lot here. Let's look at it a little carefully. No, it looks like there's a second layer. Yeah, this looks like it has 2 layers. Let's see if we can get a good video of it. So if I focus in on that, if I give it a tap, you can see it starts to mix, and then it separates out. There's a second layer. The line between the 2 layers is right here. So these are not miscible, they're immiscible, but it looks like some of the ethanol did dissolve in the hexanes. Up next, methylene chloride and ethanol. So here's our ethanol test tube. I'll add some methylene chloride. Let's see, did I add about a milliliter? Not quite a milliliter yet. And again, I'm assuming volume's conserved, approximately conserved when I mix these. It's all approximate stuff. Okay, so how does it look initially? Looks like it dissolved, huh? Well, I don't know. Let's bring up nice background. Give it a chance. We'll give it a good stir. It looks like it's soluble. So the pretty polar ethanol is miscible with water, so it's pretty polar. Looks like it's miscible with methylene chloride, which is pretty nonpolar. It doesn't mix with water, but the methanol or the ethanol is more nonpolar than water, so kind of makes sense. This suggests to me that the hexane, which was immiscible with ethanol, is more nonpolar than the methylene chloride here, which is miscible with methanol. Nice. Now for ethanol and diethyl ether, or just ether. So the ethanol, it's pretty polar. It's soluble, miscible actually, in water. And the diethyl ether was not miscible in water. It made 2 layers in water, so it's not as polar. Let's see if they meet in the middle or not. So let's set up our camera here. Here's my test tube I've labeled for ethanol and diethyl ether. As I was drawing up the diethyl ether, it started dripping. So I just drew up some more and pushed it back in to cool the pipette. Alright, let's see. I think I've added about a milliliter. I think my graduation's starting to wear off on this test tube. Okay, let's see. Is it miscible? Okay, let's get the background. And then I'll give it a stir. It looks miscible. I don't see any lines for 2 layers. No, this looks miscible. So ethanol is got some nonpolar to it, huh? It's good enough to dissolve ether and methylene chloride at 50-50 concentration. So I'm assuming that means they're miscible. Now to test diethyl ether against 2 solvents it hasn't been mixed with, hexanes and methylene chloride. First, I'll add some diethyl ether to both test tubes. Ether and hexanes. So ether appears to be a bit polar. It's got some oxygen-carbon polarity. Where hexanes is completely nonpolar. Will the ether and hexanes mix together? We know that the ether, even though it has some polarity, it's not miscible with water, so it's not super polar. Here comes the hexanes. About a milliliter. That'll be close. Yeah, that looks like about a milliliter. And how's it looking? Sorry, I didn't have the camera angled well. It looks like it's dissolved. Let's get ourselves a good background in there. Let's try to stir it to make sure. Put my spatula in there, give it a good mix. And yes, that looks miscible. I don't see 2 layers on this one. Nice. So it looks like diethyl ether and hexanes are miscible. They're both nonpolar enough to dissolve with each other. Ether and methylene chloride. So they're very similar in that both of them were immiscible in water. They didn't dissolve completely in water. And both of them were miscible in the very nonpolar hexanes. So they seem to be alike. So if like dissolves like principle applies here, they should be miscible. But we don't know until we test it. Let's experiment. Methylene chloride. Got my heavy bottle of methylene chloride. That methylene chloride is very dense. Let's see if you can see if it drops to the bottom of the test tube as I first add it. Did I add about a milliliter? A little bit more. Okay. So yeah, that looks like it's miscible already. Let's stir it with a nice background. Yeah, this one did not require stirring. I think it was already miscible, dissolved in each other right away. They're pretty nonpolar, so the meniscus, does it look like their meniscus is flat across? I gotta move it up. Looks pretty flat. It doesn't look like it grows up that much. So yeah, it looks like ether and methylene chloride are miscible. The final combination will be methylene chloride and hexanes. And as I was drawing out the hexanes again, I noticed I didn't ever draw in the other ones the 2,3-dimethylbutane, which is another component of this hexanes. And there's other hexanes as well here, I believe. So hexanes is very nonpolar. Methylene chloride is proven to be pretty nonpolar because it doesn't dissolve well in water. I actually said in the last video that they were miscible. I gave it away. Let's confirm that now. Here we go. I've got to first add some. I'll add the methylene chloride first. Doesn't really matter which one I add first. About a milliliter. Then I will add my hexanes, very nonpolar hexanes. Okay, do they look miscible yet? Oh, it looks like 2 layers initially. So let me give you a good background and we'll check this out. Am I seeing 2 layers here? Thought I was for a second there. I don't know. I don't think I'm seeing 2 layers. Maybe I was imagining it, or maybe it was initially not mixed yet. We'll stir. Yeah, this looks like a single layer. Definitely looks miscible. Yep, hexanes and methylene chloride, very nonpolar. And like dissolves like, so they're miscible. We've collected all our data for this part of the experiment, so it's time to clean up. We have most of our things are going to go in the waste container. Remember, we could put water down the sink drain, and we could put ethanol down the sink drain. But can we put, say, ethanol that can go down the drain that also has methylene chloride in it? No, methylene chloride you saw was a very organic solvent. It's not very soluble in water. So we need to put the ethanol and the methylene chloride together in the waste container. And from our mixtures, all of the test tubes have to go in the waste container except for our one lone water and ethanol. This is a 100 proof water and ethanol we're pouring down the drain, but denatured, so you don't want to drink it. You can put that in the sink drain. But the other ones cannot go in the drain. They have to go in our waste container. So let's head over there. Okay, so when I put these in the waste container, let's say, for example, I just grab the ethanol and methylene chloride container. After I dump it in the waste container, do I need now to rinse this out with the cleaning solvent acetone? Let's think about this. Acetone is another thing that if I put in here has to be disposed of, and that costs money, and it's not good for the environment. Pretty much everything we do is not great for the environment, but we're learning, and that's going to hopefully make us better citizens of the world and the environment that way. But the ethanol and methylene chloride, they are very clean solvents. I believe they're actually higher purity than the acetone. Also, the ethanol and the methylene chloride are very volatile, so they'll evaporate quickly. So this test tube is actually cleaner now than if I rinse it out with acetone, in my opinion. So I'm going to say that just needs to evaporate. I don't need to do anything else to it. Well, except for later I'll clean off the outside of the Sharpie part. Easy enough. Now, same goes for water methylene chloride. Yeah, the water was deionized water, so that's pretty clean. If I was worried about the water taking a long time to dry, that might be an issue. I may rinse it out with acetone because acetone will evaporate quicker than water, and the acetone dissolves the water. But I'm not going to worry about it. I'll just give it time to dry. I've got lots of test tubes. If it doesn't dry by next time I'm here, I'll just use another test tube. And then same with the rest of them. Hexanes, methylene chloride, very clean solvents. So this glassware is probably cleaner than when I started the experiment. Methyl ether, hexanes, yep, I just dumped all these in the waste container, and then all that. A lot of times students get in kind of a robotic habit of just every time they want to put something in the waste container, they feel like they have to squeeze some acetone in there and dump that in the waste container. But you don't have to do that. It's usually more fun if it's solid. Yeah, think about what you're doing and save the reagents, the chemicals. It saves you money and it helps the environment.